me please welcome Amy Cartwright, who I mentioned earlier, who's from Ibstock, and is obviously a senior school. Amy takes a very creative view to using computing. Let me hand over to you then.
So I think it goes without saying, and it's actually already been mentioned a couple of times this evening, that having a strong computing skill set is essential for the future and the future in the workplace. But being able to be creative within that skill set, to me, is where the interesting things start to happen. So if we think about jobs, software designers, hardware designers, even things like network infrastructure, data visualization, game developers, machine learning, robotics, etc., etc. It's a creative industry, and we absolutely must have creative and innovative thinkers in it. I'm not denying the need for technical ability. Yeah, I absolutely appreciate and understand that there is a need for those baseline skills. And the qualification in school, sort of GCSE and A-level, they provide this. But because of the nature of those qualifications, there's a massive time restraint. There's just not really the time, I find, to prioritise creative work. That can be really difficult. And so my solution to that problem, it is by no means, it's being tried and being tested. It is not only a complete solution. But I try and nurture creative thinking in my computing classroom at Key Stage 3, because I teach Year 7 all the way through. And I really want my pupils to start the GCSE already knowing that it is an innovative, it's inventive, it's exciting. I want them to understand what the subject actually is, and it also helps recruit them into the subject, because it's optional, and I want people. I'd rather teach people than a classroom, of empty computers. So this seems weird, I appreciate, it makes sense, I promise. So I'm actually a Roehampton alumni, and I graduated from the BA in Dance Studies in 2013. And up until 2017, I just worked in the arts. I dance practice, choreographic work, and I've always been interested in thinking about beyond the human body. And during my undergrad degree, I started to write about animals and dance, and it was interesting. I love sci-fi, and I really, really, really wanted to make a computational dancer. Didn't know what that was at the time. So I did an MA at Goldsmiths, MA in computational art, and I learned how to code, and I used processing, P5.js, Open Frameworks, and Arduino. And those are the 4 things that I started with. That's 4 separate languages, but with libraries built on top of them. And I used these skills to create a series of computational choreographies. And the series is called the Non-Human Dances, and each one experiments with different types of algorithms. The one I'm making at the moment is machine learning. And live data from the dancer feeds into the robotic dancers. Now, I do this, and I do that in the small bit of spare time I have, but I also teach computing, as I'm sure you figured out. And I'm the head of the subject at Ibstock Play School, and that gives me quite a lot of flexibility with the way that I manipulate my curriculum. And that's why I've spoken to you about this at the beginning, and you'll see how it sort of trickles down later on. So, this is my opinion. The problem, like most secondary schools, we have children that enter into our school in Year 7, and they've come from loads of different schools. And they inevitably then arrive with a really vast range of experience. And I often find in Year 7, there's like a small number of pupils who have an active interest in the subject. They come in and they're like, I've built my computer, I've made a game, and it's really exciting. And then I have this sort of even smaller number of pupils who have experience with text-based programming languages, and that tends to be HTML and Python, generally. Pupils, often who have very little experience with computing, they often arrive at my lessons assuming that it's going to be really hard, or with this assumption that it's just going to be really boring. I mean, that's quite offensive, really. I haven't even started yet, but this is something that they've really got in their heads about it. And so, in Year 9, it becomes optional. So I've only got 2 years. I've got to get, in those 2 years, I really want people to do my subject. And so a lot of my focus in my curriculum is on that. It's on recruitment, it's on, but without losing the integrity of the subject. Yeah, I appreciate that there are things they must know, and I really, hopefully you see that I do actually teach them computing. I don't just, song and dance. Creative computing at Key Stage 3. I advocate for it so much because it is the best thing ever. Creative computing, just in case you don't really know what it is. Now, it's the use of computational systems to create art. Computational artists, they tend to have really advanced programming skills, but they've got a desire for concept. They want to work on an artistic concept, and they want to use the technology to do that. So, this is not all my work, by the way, but friends of mine. So this is great. This door will only open if you smile. It's a bit offensive to some people, but it's interesting. It uses facial recognition technology, and it's not just a sort of casual smile. It's like a really intense, cheesy smile. Fits into the category of computational art. They're dealing with the concept there. This is a friend of mine, Saskia Faker. She makes these types of artworks every day. She has a daily practice. And she uses P5GS for this, which I'm actually going to talk about a little later on. This is actually me, but also in someone else's work. And that was a piece that the sort of LEDs were interactive to the movement that you were doing in the space. And this is great. I cannot credit the student who did it because I saw it at Goldsmith's BA exhibition. These little busts, they have holograms on them, and you tweet. So you tweet at the Watsons, and they develop a life based on the things that you've tweeted. And they have conversations like between them. And you can go and put on little headphones and listen to these around the dinner conversations. And it's massively interesting because you've got all of these things that have been tweeted in, and it's just fascinating. So this is like where I come from. This is like the background and the thing that I'm super interested in. And so, when I came then to teaching in a school, it was a bit sort of like, ugh, because I was like, what is that? Okay, interesting. And I really wanted to see if I could just, these are advanced obviously, but bring some of the stuff in there and build some creativity. So it's huge because it's great. I use P5.js, and it is a library that is built in JavaScript. It is written in JavaScript, and it allows for some creation, as you saw, some quite interesting artwork. It allows me to teach the basics. I teach everything that you would expect: variables, conditions, iterations, repetitions, functions, etc. But instead of having outputs that sort of look like this, I can get my pupils to create outputs that look more like this. And already they're slightly more engaged. Already they have a little bit more of an interest. So if I show you this example, I realise it's a bit blurry. I think it's when I translate it into a GIF, I'm sorry. But the structure of the language hasn't been compromised by adding this, by adding this library and using this library. It's still JavaScript. And the pupils understand, if they can understand how to get the circle on the page in the first place, they've understood the coordinates. But then if they then start to add variables in, and they say, okay, well now when I change that variable, I can actually see what happens. And now I'm understanding that when you change variables, you can have something. You can create something that the data is passing through the program, and you can actually see it really clearly in this. And then when you go the next step and add the conditional statement in, they can see the bounds of the conditional statement. And they make loads of mistakes all the time. The border just like shoots off the end of the page and is gone forever. But ultimately, those mistakes and narrowing down the variance of the conditions, I find it a very, very, very helpful way of getting them to understand what each of these specific pieces of logic are doing and what the purpose of it is in our program. So this is an extremely pared down, so please don't judge me down, this isn't what I teach, extremely pared down variant of my Key Stage 3 curriculum. And I'm showing you this now because first of all, I slightly controversially only introduced Python in year 9. I'll explain that in a minute. But each year has a sort of learning theme. So in year 7, it's all about discovery. It's what is a computer, what is its job, what does it do? And within these, it's not, I'll refer back to what we heard earlier, it isn't all programming. In how computers work, that's where we're sort of learning all about like the hardware of the machine. We take it apart and we pull, have a look at all the little variants. And in our robotics module, I managed to sneak Excel in there actually as one part of the project. So I make sure that they are interacting with IT, digital. I'm bad at digital literacy, it's a weakness, but IT, digital literacy, and along with this sort of creativity, because as I said, it is really important that it isn't all bells and whistles, it has to be practical as well. Year 7, sorry, I said year 7, year 8, it's about sort of computing in the world. So what actually are the implications of this subject outside? This is the big recruitment year as well. This is the year that I have to get them interested. And you know, we build websites, we do an app. The app actually is, we only program a minimum viable product. The whole concept of this is an IT project. We start from ideation, we go all the way through, Dragon's Den. I even get other teachers to come and sit at the front and, you know, like choose and make, you know, we turn it into a whole big thing, and they really enjoy that. In year 9, it's about the GCSE. You know, I have to start preparing them for it, and I have to start making sure that they understand what it is that they're going to be doing for the next 2 years if they choose it. And so that's why we introduced Python. I teach the EdXL curriculum, and now they've got this on-screen assessment, which actually I'm a fan of. But they need to be able to be quite good at it. So we have to work hard at that. And now I use Python a lot. I'm going to regret saying this maybe to this particular audience. I don't find it very inspiring as a teaching tool. I find it, especially when we see the type of things that I prefer to work with, I find it can be quite dull. And I find that a lot of the pupils that come who were already scared of the subject, they start with Python and the hands off immediately, and they're not interested anymore. But if I can convince them with, you know, the P5JS and the way of working there, it does work. It tends to be a bit better. So I'm just going to sort of narrow in a little bit. So in year 7, the program module, it's not. I use a few different things actually. All of these go into one module. I have microbit. I use VEX Code. I love VEX Code. Has anyone come across VEX Code before? It's very much like you know, drag and drop Blockly, but they program this virtual robot. It's really fun. They really enjoy doing that. And also, this is Blockly Games. It's quite old, but I quite like it actually. And actually, I relied on it a little bit over lockdown because it's traditional. It's very much, you know, it's an introduction to sort of standard sort of gamified tutorial system, which was helpful when I wasn't always there face to face. I don't use Scratch because I find that pupils who have had extensive programming experience in prep school, like after-school clubs, or they've been on holiday camps, they're a bit sort of scratched out. They've done a lot, and I know it's used a lot in primary school as well, and it's great, and we do it in clubs and things like that, but in my curriculum, I avoid it because I want the jump to senior school to feel as a progression. I want them to feel like they're moving into something new, they're learning new skills. I don't want those pupils who are possible GCSE candidates because they've got so much interest to get bored. That is also something we have to consider. Something else that's important to me, just really quickly, when I choose things like this, obviously first of all it's creativity. Can I be creative with the tasks that I'm setting to these pupils? Secondly, it's this concept of auto-differentiation, which I love. So microbit, you can, I don't know how people probably know about this, but you can code in JavaScript to Python, which is really helpful. I can teach the whole lesson using blocks, but in the corner of my PowerPoint down here, I'm like, oh, but if you want to do the Python, you know, here's some helpful tips. And I have some pupils who do that. Similar types of thing in VEX Code, they can code it in Python as well. So you've got those more advanced pupils that have an active interest, then both of those programs are really great. Blockly Games doesn't do it in the exact same way, it just shows it you afterwards. But that's why I often use it, and I often actually send some of my really hesitant pupils into Blockly Games, and they sort of eventually like, oh, yeah, I can do this, I can figure it out. Where am I up to? Oh, yes. So, I admit, as you saw, P5JS comes in year 8. And admittedly, I do find JavaScript can be quite hard to work with in the classroom, especially if you've got a large classroom. There are so many little quirks to the language that aren't there really as much in Python. Parentheses, curly brackets, you know, where the code needs to go and the sequencing in order to get it in the right place. And so this is one tactic, bootstrap program. I provide them with something like this in the early lessons and say, you know, one, it introduces them to the structure of the program, but also it gets them used to this idea of commenting. My pupils never comment enough on their code. So You know, I literally tell them, like, this is the end of draw. Please don't remove this. Like, end of setup. Definitely don't remove that. And then also, well, you should write all your setup code in this section here. And remember, it's only going to run once. And actually, this is a sort of a really short version. I usually leave massive gaps in between each of these things as well, so it's much more sort of easy for them to understand. By removing the need to focus on all of these sort of niggly intricacies, I find that I reduce the number of stumbling blocks for my pupils. So now we're not just focusing on sort of, oh, where does that semicolon go, and where, you know, where's the indentation need to be for this specific thing. We're actually focusing on the logic of what a conditional statement is and what a for loop is, and they can sort of, they'll get this. They will. They in time and in practice, they understand where the indentations need to be because they've seen it multiple times. But you know, I think we all have those pupils. Oh, miss, I can't do it. I don't. It's too hard. I don't understand what's happening. I get this a bit less when I work with these types of bootstraps. It's been mentioned before. Pair programming is a must. I do it in almost every lesson as well. Sometimes group programming is harder in COVID times, but you know, sort of like make do and have some quite low classrooms. But you know, we still try with that. So well, back to these. These were on the beginning slide. So this is just a small result of the assessment for my year 8 P5JS. I tell them they have to pick a song, any song, school-appropriate song, and produce a visual representation of that song. As you can see, with Rocket Man, some are quite straight, some are very, very literal. That is fine, I don't mind. But also, you know, we have like some really interesting abstract interpretations coming out. Many of these do actually move as well because they have to use the loops and the conditions, but the slide looked horrific, so I just went with the still image. But when I do the assessments, it's always open book. Programming assessments for Senior 7 and Senior 8 and Senior 9 actually, they are allowed to have their resources with them, they're allowed to use the internet, they're allowed to even ask me actually, I try, you know, not to just tell them, but they're allowed to work together. It replicates what actually happens in the real world. Yeah, none of my robots have been made by me sitting by myself in my room like this, not one. I have help, and also I think it just removes, again, the stress of the situation. You know, we're focusing here on getting to an end result and getting to something exciting and interesting. We're not focusing on, you know, oh well, you know, I would have given you that mark, but that curly bracket wasn't in the right place, so I can't do it. You know, I'm trying to remove that sort of temptation for negativity that seems to arise quite often in the subject. So, yeah. Now, as I said, I very much appreciate that while I'll always advocate for teaching creative computing, there are, you can't adopt a full creative computing curriculum in schools. Like, it's not possible. I tried. It's not possible because there are certain things that the pupils need to be able to do. They've got this whole theory modules that are set up in the GCSE, and it is to the benefit of our you know, pupils in Key Stage 3. If we start trickling some of that down a little bit. And so the way that I do that is I try and work quite creatively, and this is just a few examples. So searching and sorting choreography. I really would have liked to have had a video, but COVID doesn't really allow that to happen at the moment. Instead of sitting in a classroom to learn about searching and sorting algorithms, my pupils go out onto the playground, and we learn it like a dance. I don't tell them this because they probably wouldn't do it. But, you know, I give them all each individual roles. They stand in a row. They've got big post-it notes with like some type of data, a number or a letter, and they move like around the choreography. Like, oh, okay, yeah, that would be me. I know that's this one, and then they figure out the structure. And as with a dance, we rehearse it. We do it quite a few times. We come back to it quite often. And sometimes, pre-COVID, I would say, starter would be on the board as they come into the lesson and say, okay, you're going to perform the merge sort in 5 minutes, so get ready. And they do it. And actually, having that sort of physical understanding removes a level of abstraction from the program. Same concept, really, with the CPU play. I tried this for the first time sort of just in that sort of snippet in between lockdowns, and I gave each component was a character in the play, so each component in the fetch, execute, decode cycle, which I guess is a bit more just a CPU, and they had to write a script for it. As a class, they came up together with a script, and so and then I fed in post-it note data again, and they interacted with it, so like, and they are okay, I'll take it from here, and I'm going to put it on, and then having that concept, one was quite an interesting way of getting them to understand what is actually happening, I found, better than videos which I've tried before, better than me explaining it because I end up stumbling over it because there's so many different intricacies in that process, but also better because they remember it. You know, they go, oh yeah, it was that really embarrassing thing that one time where we had to stand up and recite those lines, but actually I kind of remember doing that, and I remember that I handed it to Isla, and she was that character. Oh, I got it. Yeah, that it does work. This is one of my pupils, so I know it's not 100% accurate, but again, I think this is a tried and tested tactic. I was having pupils over lockdown who were really struggling with just the sort of heaviness of some of the theory that we were going through, and so I asked them to write a song on any topic that they chose. I picked this song because it has good rhymes, but you know, I think generally when I force the pupils to work on creative tasks like this, it really forces the pupils to think quite deeply about the concepts that they're working on. You can't do something creative like this if you don't fully understand a theoretical topic. So if you don't fully understand how a merge sort works, it's going to be that merge sort choreography is going to be a disaster because you're going to be crashing into each other. So you have to start again, think about it. If you don't understand what's going on with the CPU play, the data is not going to go around, and again, it's not going to work. I do these tasks at Key Stage 3, generally, usually 9s, you know, I don't try to go too far down, but I do often revisit them with the GCSE, and pupils are almost always less keen to act and dance at that age. But sometimes I force them to do it. Sometimes, you know, and sometimes we revisit in a sort of more condensed version, so it's not quite, you know, stand up and form it for everybody. It cements understanding. I really do think that. So before I finish, I just wanted to two resources, two of the most valuable resources that I've come across. I didn't want to overwhelm you with stuff. The coding train. This guy is absolutely bonkers, but and first time you watch one of his videos, you're going to be like, oh my word. But he made it. He made P5JS. He made the program. He's the leading expert in it, and his videos are great fun. They are pupil friendly, so you can absolutely give them to your pupils. He does things like 10-minute programming challenges. How can I make it rain on the screen? 10-minute programming challenges. Oh, can I make a program that lasts as long as this one song? You know, he just does all these like fun, creative, and exciting challenges. He also has tutorials. So here's a beginner. From the very first, you know, I've opened my computer. What do I do? How do I get to P5JS? How do I access it? How do I get that circle? How do I make it bounce? He has, I think, several beginners tutorials, several intermediates, and so on. He has P5 with machine learning, P5 with robotics, P5 with Arduino. It's very extensive. And this is great. I actually came across this only very recently. It's a creative medium. I'm just recommending this because I've actually stolen a few exercises from my lessons. Just recommend some really nice activities that you can do with your pupils in the lessons as a creative task. So yeah, I mean, I hope that there has been something of interest in all this, and I appreciate that. You know, I appreciate that I have an unconventional background, but I do think it actually really helps me to sort of make. Well, you know, at times it helps me to sort of figure out where I can help people and push them into that sort of creative environment. As I said, it is a creative industry. They should be thinking creatively. Like, there's no point in them sitting at their computers feeling very stressed, looking at a black and white screen all of the time. Relevant sometimes because they need it for the GCSE, but not relevant all of the time. And if I can get them to understand that they can do it, you can write this code, you can make that circle move, and it's really rewarding when they do that because they feel really sort of accomplished. I think probably already agreed that it was a creative subject before I started talking. I think I don't think I've managed to convince you of that because I'm sure you were actually already there. But, you know, I don't want my pupils to be able to just do okay in the world because they can use a computer. I want my pupils to be those people who are making new stuff, who are, you know, innovating and understanding. And they're not necessarily programmers, all of them. That's fine. But, you know, they're understanding how to work with technology in a creative and innovative way. So I think that that's going to be best for them when they, you know, in their futures.
Thank you. And when you're talking to them, they're doing all this work. Do you talk about careers? Do you bring people into school to talk about potential?
Yeah, so people into school less so because of COVID,
yes.
But also, yeah, it's just, I've actually only been teaching at the school for 3 years, and there's a lot of time spent setting up the syllabus, so that's kind of on the agenda for the future, because I really think that they can learn a lot. They have, I mean, I pretty much show them just like artworks almost every lesson, just like, have you seen this cool thing? And it's usually stuff I found on Twitter or something like that, and, you know, we talked for a really long time about Amazon Fresh. That was great. You know, that opened, and we spent almost an entire lesson discussing that and discussing the implications. So I try and make sure that they've got, yeah, a real-world understanding of how computing is happening around them. Yeah.
Thank you. Any questions, Brandon? Yeah, over there at the back.
What program do you use for app development?
So we only do minimum viable product. And so we use AppLab for that because they've only got 1 lesson to make their minimum viable product because of the time restraints. Have you used AppLab?
No, I've used AppShare, but since COVID, I'm having issue with getting through to them. To get the packet because they have made the free version.
Oh,
and then we're willing to pay for it, but we just can't get through to them.
Yeah. AppLab is browser-based and it's free. What age group are you working with?
Key Stage 3.
Oh, yeah, absolutely. It's drag and drop. So it is, but as I said, we only do it in 1 lesson. But it's great because you get your little image of your phone on this side, and then you can drag it across. And I think we haven't ever done this because it's not really part of my module, but I'm pretty certain that there's a link that they can then put in the browser on their phone and run the app on their phone, which is quite cool. So yes, I definitely recommend it. It's part of code.org, so they've already got logins to that. It syncs up.
Another question? Sure.
First of all, I just want to say I'm massively inspired by all the things that you've just been talking about. I wish I was in your class.
Maybe you can come and tell my pupils that.
I come from primary, obviously, and just thinking about this P5JS, which I'm not familiar with at all, do you think that that would be accessible for your sort of older primary kids, or do you think, it was quite interesting hearing you talking about how, you know, they're sort of scratched out by the end of year 6, because that is what we use usually.
Yeah.
You know. Do you think there's scope to use other programs in primary, or should we just stick with Scratch?
I mean, I actually have a few pupils, when they started in year 7 this year, they came in, and I've got like a bunch of P5GS stuff on one of my walls, and they were like, P5GS, and have done it in primary schools. And this is always as a club though, so it's always those pupils who already have that active interest beforehand. I think I'm nervous about bringing it further down into year 7 because what I don't want to do, I'm still battling the perceived complexity. I don't want to make it too hard. But I'd give it a try maybe, but I'd be tempted, you know, I don't think there's anything wrong with Scratch. I think Scratch is a fantastic program to use. And like I said, the only reason why I don't is because I just want that sort of progression. Some of the stuff I was showing earlier, Vex Code, definitely. They could definitely do that as drag and drop. Microbit, definitely. You know, with Microbit, like our module at the moment, they make these little tabletop cardboard robots that sort of like, you know, wave at each other. And, you know, it's fun, it's cute, and it's very easy. And things like that, yeah, I definitely, what you could do, actually, you could do Microbit, turn on the JavaScript, see if they get on with that, and then, okay, well, we actually, you know, try some of them on